x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we have a point 5, negative 7, and that's on the terminal side of theta. What that means is when I plot this point 5, negative 7 over 5 down 7, this only goes down to negative 6, so we're going to go down one more. And this angle that we're talking about is an angle that starts on the positive x-axis and travels all the way around. So we're talking about this angle here. When we're talking about that angle, it takes us out of a right triangle. So we no longer have a right triangle. This angle is larger than 90 degrees, but we can use the fact that this is a right, that we can find a right triangle here to find these different values. So I'm going to extend this up to the x-axis. We're going to identify the different pieces of our right triangle and then talk about how they're different because this angle goes around this way. So the things that are the same is that this length is 5. Or if I go from 0 to 5, that's a length of 5. And then I went from 0 to negative 7, that is a length of 7. Then I can use the Pythagorean theorem, 5 squared plus 7 squared equals, and we'll just try to find this third length, c squared. And so that's going to be 25 plus 49 equals c squared. So 74 equals c squared, and c is equal to square root of 74. We're going to use that as this length over here. This is the square root of 74. Now we're going to find the sine, cosine, tangent function values, but after that we're going to have to talk about if they're positive or negative because they're in a different quadrant. So sine theta and theta is always found at the origin. So we are looking for this angle here, but we're using this angle inside here, which is called a reference angle. So when we use a reference angle, we have to identify when things are positive and negative. So the sine of theta, this would be opposite, this would be adjacent, and over here would be a hypotenuse. So sine is 7 over root 74, which simplifies to 7 root 74 over 74. We're going to have cosine, which is 5 over root 74, which simplifies to 5 root 74 over 74. And the tangent, which is opposite over adjacent, which is 7 over 5. And then we're going to have the cosecant, which is square root of 74 over 7. And the secant, which is the reciprocal of cosine, which is square root of 74 over 5. And the cotangent, which is the reciprocal of tangent, which will give us 5 over 7. And that's just part of the story because we use a reference angle. We use this angle on the inside, but this is the angle that we're really interested in. So it's going to have different values. And so in quadrant 1, all sine, cosine, tangent are all positive in quadrant 1. In quadrant 2, sine and its reciprocal are positive. Quadrant 3, tangent is positive. In quadrant 4, cosine is positive. And we'll talk about that in a minute why. So we're in quadrant 4, so cosine is positive, so cosine and secant, its reciprocal, are going to be positive. And all the other ones, sine, tangent, cosecant, because it's reciprocal of sine, and cotangent, because it's reciprocal of tangent, are going to be negative. Which leads us to these trig functions down there. Alright, we're going to talk about trig functions of any angle on a coordinate plane with a vertex at the origin. So if the vertex is at the origin, and we know the terminal side of an angle, then we'll be able to use these trigonometric values. Alright, so the first value we're going to use is, we're going to use y. The y value is going to be on top, and then The distance formula, which is found using the Pythagorean theorem, is going to give us the square root of x squared plus y squared. And since these are reciprocal functions, if this is what sine is, then cosecant is going to be the square root of x squared plus y squared over y. For the cosine function, we're not going to have y on top. That would have been the opposite. The adjacent side is going to be x. So we have x over the square root of x squared plus y squared. And secant is the reciprocal, so the square root of x squared plus y squared over x. And tangent is just going to be y over x. And its reciprocal, cotangent, it's going to be x over y. And you can find we did this problem over here using the Pythagorean theorem and the idea that we have these, all the trig functions are positive in quadrant 1, and sine is positive here, and tangent is positive here, and cosine is positive here. But if we hadn't, we can still use this. So let's use it with this one over here. We know that y here, we'll use this point 5, -7. So for the point 5, -7, we know that the x coordinate is 5 and the y coordinate is -7. And what we can do is just plug them into this formula. So we would have -7 over the square root of 5 squared plus 7, -7 squared, which is -7 over the square root of 74. And that's the same thing that we got over here. And you'll find it works for all of these functions. So now we have all the trig functions for any coordinate point on the axis. So I have the formulas up here, and all we really need to find the exact values of the 6 trigonometric functions at an angle theta is the values of x, y, and the square root of x squared plus y squared. So we're going to find the exact values of the 6 trig functions at this angle theta. So theta is here, that's this angle that is more than 180 degrees. And we know that the x, y coordinate is -square root of 3, -1. So x is -square root of 3, and y is equal to -1. So the first thing I'm going to do is I'm going to find out what x, y, and the square root of x squared plus y squared is equal. So I know x is equal to -square root of 3, y is equal to -1, and the square root of x squared plus y squared would be the square root of -square root of 3 squared plus -1 squared. And negative square root of 3 squared is 3. -1 squared is 1, and so I get the square root of 4, which is 2. So the square root of x squared plus y squared, in this case, is equal to 2. And now I should be able to find all the functions because I already know the pieces that go in here. So the sine of theta is equal to y, which we know to be -1, over the square root of x squared plus y squared, which is 2. So -1/2. And the cosecant is the reciprocal. So when I flip that, cosecant is -2 over 1, or just -2. And the cosine of theta is x over square root of x squared plus y squared. We know that to be -√3 over 2. And the secant of theta is reciprocal, so it's -2 over the square root of 3, which we will rationalize to -2√3 over 3. And then we have tangent. And tangent is just y over x, so it's negative 1 over negatively 3, negative 1 over negative square root of 3. We know a negative divided by a negative is a positive. Rationalize by multiplying top and bottom by the square root of 3. And I get square root of 3 over 3. And the cotangent is the reciprocal. So it would be negative root 3 over negative 1, negative root 3 over negative 1, which of course simplifies to square root of 3. So if you have these formulas and you have them memorized, then if you know x, y, and the square root of x squared plus y squared, you can just plug those into the trig functions. If not, you can do what we've been doing previously. We'll do one more example. All right, for negative 4, 3 is a point on the terminal side. Find sine, cosine, and tangent. So negative 4, 3. Well, the first thing I want to do is, just like I was doing over here, identified x equals negative 4, y equals 3. And then I want to find the square root of x squared plus y squared. So we'll do that work in this space right up here. So the square root of negative 4 squared plus 3 squared. So that's 16 plus 9, which is 25. Square root of 25 is 5. So this is just 5. And now we're going to find sine, cosine, tangent. Sine of theta, cosine of theta, tangent of theta. All right, so the sine is going to be y over the square root of x squared plus y squared. So it's 3 over 5. Cosine is x over square root of x squared plus y squared, so negative 4 over 5. And the tangent is y over x, so 3 divided by negative 4. But we always write that negative either in the top or out front, so negative 3 fourths.